Hello class, today I will show you how to solve for a nonlinear inequality of one variable. Behind me is a perfect example of a nonlinear inequality of one variable. We have x to the third power minus 9x is less than or equal to 36 take away 4x squared. We only deal with one x. Therefore, we only deal with one unknown. And this is the non-linear because the highest power is 3. Okay? If we want to work on this type of problem, remember we have to follow these steps. We solve the given inequality as a solution. And then we line up all the solutions on the number line. And then we test each interval on the number line by the yes-no method. I will show you how to do that. First, I have this given inequality. I am going to rearrange all terms to one side of the equation. So I have x to the third power, and the next term would be x squared, the negative 4x squared, bring over positive 4x squared. Then the next one is negative 9x. And then the last number is 36. Positive 36 over here. I minus 36 on both sides have negative 36. And it's less than or equal to 0. So I have a 4-term polynomial compared to 0. And remember, the inequality is less than or equal to. Next step, we have to solve. We have to solve this as the equation. We ignore the inequality. We look at x to the third power plus 4x squared minus 9x minus 36 equals 0. And we solve for a nonlinear equation of one unknown by zero factor property. Here I have 4-term polynomial. How can I solve for this? By grouping. I group the first two, and I group the next two. For the first two, I can factor out x squared. So what I have left is x plus 4. For the next two, I am going to solve by factoring out negative 9. Negative 9 because this number is the leading coefficient. I take out negative 9. And here I have x plus 4 left, and set it equal to 0 again. So from the 4-term polynomial, I narrow down to 2-term polynomial, and each term carry a quantity x plus 4, so that is the GCF. Then we factor x plus 4 out. For this term, I took x plus 4 out, so I have x squared left. For this term, I have negative 9 left, equals 0. And then I break this down further because x squared minus 9 is a difference of two perfect squares. So we break it down as x plus 3, x minus 3 equals 0. We use zero factor property to solve. So I end up with 3 solutions. One solution is negative 4. The other one is negative 3. And the last one is 3. So we end up with 3 solutions. So I am going to line them all up on the number line from small to large. So the first number I mark on the number line is negative 4. And the second one is negative 3. And the last one is 3. So these 3 solutions will divide the number line into 1, 2, 3, 4 intervals. So we have to shade in the correct one. Now we want x such that this expression will be less than or equal to 0. So I am going to pick one interval to test. And you want to pick an easy number to test. For this case, okay, the easiest number that appealed to me is 0. So I choose to test x equals 0. I choose to test this interval. I go back to this step. I am going to replace 0 in for x. The reason I pick 0 because when you substitute 0 in, you cancel a lot of terms. So 0 to the third power would be 0. 0 to the second power times 4 would be 0. 0 times -9 would be 0. So we only have left -36. Is this number less than or equal to 0? And if it is yes, so all the numbers that are between -3 and 3 would fit this inequality. So this would be yes. And the nature of the testing is alternating. If this interval is yes, the next one would be no, and this would be no. This would be yes. So we shade on the yes interval, and at -3 and 3 we use the bracket. At -4 I also use the bracket because we do have the equal sign in the inequality. Then you write the answer as interval notation. So I would write it over here, so hopefully you can see it. X belong to, I take this interval from -infinity up to -4, union. We may run out of space, so I continue to write my second interval down here. -3, 3. So this is step-by-step how to solve for a nonlinear inequality of one unknown. I just want to summarize it. First, we solve as the equation, and we get the solutions. Then you line up the solution on the number line, and then you pick one interval to test, but you have to pick a number that belongs to that interval, and you go back to the original inequalities where you have all the terms to one side of the equation, and you want to compare to 0. It's easier. If 0 is not one of the solutions, then it's nice for you to pick 0 as the testing number. It's so easy because when you test 0, a lot of terms cancel out, just as I did. And then if the testing interval turned out to be good, that would be the interval you pick as the solution interval. And then you go through the motion of yes, no, alternating the answer. And finally, at the end, you should give the interval notations of those yes interval. And that is the solution of nonlinear inequality of one unknown.